Hello YouTube, welcome to our TI92 version of 2016 BC2. At time t, the position of a particle moving in the xy plane is given by the parametric functions x of t, y of t, where dx dt is given. The graph of y, consisting of three line segments, is shown above, and at t equals 0, the position is 5, 1. In other words, x sub 0 is 5, and y sub 0 is 1. Find the position of the particle at t equals 3. Alright, well, we figured out in an earlier video that all you had to do was integrate the dx dt from 0 to 3, and since we have x sub 0 is 5, we just add that on the integral from 0 to 3, and we're going to get x sub 3, right? Okay, so let's do that. Go to the TI92. Oops, what happened there? Start that up again. Let's go into y equals, enter this function. Alright, now the function given is, now I'm in function mode on the calculator here, so it has to be in terms of x. So instead of t squared plus sine of 3t squared, I'm going to write x squared plus sine of 3 times x squared. There you go. Alright, and then we're going to integrate that from 0 to 3, find the definite integral from 0 to 3 and add that onto x of 0, which is 5, and get x of 3. And I think we've done this before. We got 14.377-ish, right? So enter that, and let's go to the home screen. Okay, let's do 5 plus second math, calculus. I think I've fixed my ludicrous speed problem here. I can scroll down here. Calculus, and what am I going to do? Integrate. Okay, now I put this in y1. So y1 of x with respect to x, and I could just do that, hit close parentheses, get an exact antiderivative, an indefinite integral in other words. But we're going to integrate that with respect to x from 0 to 3, and see what we get. And what happened there? That's not correct. That's not what I got last time. Wait a minute. What's my y1? Did I mess up my y1? What? Sorry, what happened there? Something, I didn't do the sign. Ugh. Wrong. Where did the sign go? It was x squared plus sine of 3x squared, right? Didn't I hit sine? Sorry. Okay, let me hit sine, and then of 3x squared. Whoopsie. Okay, and then diamond home. How about that? Let's try this again. And we get. That's why I had ludicrous speed on, because this takes forever. Come on. Come on. Wow, what's taking all day now? Maybe we should turn on really, really fast. No? There it is. 14.377. Yep, that's right. Okay, 14.377. That's x of 3. Now, what's y of 3? Well, look at the graph. They're giving you y. Y of 3 is negative 1/2. Look at the slope from the point 2 comma negative 1 and the point 4 comma 0. Isn't that slope positive 1/2? So we go over a delta t of 1 from t equals 2 to t equals 3. Your t becomes 3, but your y becomes negative 1 plus the half, right? So it's negative 1/2. So there you go. So x of 3 is 14.377, and y of 3 is negative 0.5, and the x of 3 is an approximation, of course. So there you go. Okay, well, something going on with my thing here. Okay, good. Okay. There you go. And of course, if you want full solutions, please take a look at my 84 version or my TI Inspire version. I'm not actually writing notes in this version, just showing you how the calculator works. Now in part B, find the slope of the line tangent to the path of the particle, or the trajectory of the particle at t equals 3. So dy dx, the slope of the tangent line and the trajectory, isn't that dy dt, which just figured out at x equals 3 is 0.5. Look at the graph. And plug in 3 into x of p, right? So how do you do that on the calculator? Let's do it. Alright, so I'm just going to do 0.5. See, I don't know if I like this ludicrous truth, but alright, 0.5 divided by y1 at 3. Alright, so y1 at 3. I'm going to leave ludicrous speed on unless it's messing me up. Okay. And we get about 0.050. That's it, right? Now there's no units here? No units here. Okay. Alrighty, let's take a look at part C. Find the speed of the particle. Now, isn't that the magnitude of the velocity vector? Isn't that x of 3 squared, which you just figured out? X prime of 3 squared, which is figured out is xp of 3. Plus y prime of t squared at t equals 3, which wasn't a 0.5 squared is a quarter. Okay, so let's do the square root of x prime of 3 squared plus y prime of 3 squared. There you go. So let's do that. So let's do the square root. Where's the square root of this thing? There it is. Of xp at 3 squared, but xp is y1, so y1 at 3 and square it, plus the 0.5, the slope of that little line segment on the y of t graph, 0.5 squared, or 0.25 if you want, 0.25. And what is that? Where is it? Where's my parentheses? There it is. And I should get 9.969ish. Yep, that's right. So that's the magnitude of the velocity vector at t equals 3. That's x prime of t squared plus y prime of t squared square rooted. And that's a precursor to part D, where we want to find the total distance traveled from the particle from 0 to 2, right? Alright, and isn't that going to be the integral from t1 to t2 of the square root of x prime of t squared plus y prime of t squared dt? The thing is that let's think about this. Wake up. From 0 to 1, y prime is negative a half, isn't it? Sorry, negative 2. It's negative 2. That's what it is. Okay. So y prime of t squared from 0 to 1 is negative 2 squared, which is 4. So I have to do the numerical integral from 0 to 1, and then another integral from 1 to 2. From 0 to 1, it's the square root of x prime of t squared plus 4 from 0 to 1, and plus the integral of the square root of x prime of t squared plus 0, because if you take a look at the slope of the of y of t from t equals 1 to t equals 2, is that a horizontal line segment, so the slope is 0. Okay, so let's write all that up on the calculator. So I need, let's see, second math, calculus, integrate. Okay, I'm going to do the square root. Okay, let's do the square root of the quantity x prime of t squared, but isn't that y1? Whoops, where's my y1 of x squared plus y prime of t squared from 0 to 1 is a constant negative 2, so squared, that's plus 4, and close the square root. And that's what we're integrating with respect to x from 0 to 1. Alright, so that part of the integral, let's see, enter, is it going to give me an exact answer or not? And it's 2.23 something, right? Okay. Now, I'm going to do the same integral Okay, but it's going to go, well, almost the same. It's going to go from, it's deleting stuff. Wait, hang on. Let's turn off, let's make it normal speed. Okay. So what did it kill? It killed an X. Boom. Okay. So I want to go from 1 to 2 now. There you go. And plus y prime of t there is 0, so plus 0 squared is plus 0 is plus, so plus nothing, right? All this does is it makes the, if you square root y x prime of t squared is going to be the absolute value if there's any negative part. And so what do we get for this piece? Now I need ludicrous speed. Okay, let's see. Ludicrous speed. Hurry up. There it goes. Okay, so we're going to take those two amounts and add them up. It should be 4.350-ish. Okay, so can we cut and paste this? Let's see. Enter. Plus. Whoops, ludicrous speed is messing me up now. Got stuck. See, not yet. Aye. Now I don't want ludicrous speed. Sorry. So turn that off again. This is sort of cumbersome. Alright, so it's going to emulate the correct speed of the emulator. And let's close that and see what we get. What I do something stupid. Okay, hang on. What did I do? I don't need parentheses. What are we doing? 4.35. Oh, yep, that's it. Perfect. Alright, so we did it with the TI94C plus notes. We did it with the TI Inspire CX CAS plus notes. We did it with Sage, and we did it with the TI92. So I think 2016 BC2 is put to rest. Alright, thanks for watching. Bye-bye.